Welcome everyone to today's basic introduction to working with R and RStudio. So today we're going to be learning about the basics of using RStudio. So what RStudio is what's called an integrated development environment. And basically this means that it's an environment in which we can work with R code in a more user-friendly way. So R itself is a programming language, like Python, for example, or like C++. But RStudio is, rather than a programming language, is a way of using that language in a more user-friendly way. So here I've opened up a completely clean RStudio session, and we're going to be using this for today's tutorial. So this, what we see here, is the RStudio interface. And I'm going to start off today's video by giving you a little tour of the different features that we can see when we open up the RStudio window. And so feel free to open up your own RStudio on your own computer so that you can follow along with the tutorial. So what you'll notice is that we have these four main sections, or what we call panes. And how we view these panes can be tailored to your own preferences, how you prefer, but we usually have these four panes. So here on the top left, we have the place where you're going to be writing your scripts. And then on the bottom left, we have what's called the console. And this is where you can also test lines of code, and also where you will see the output of your code as you run it. And then here on the top right, we have the environment, and we have history, connections, tutorial. So importantly, we should know that in this environment, everything that we create during our R session, and also anything that we load, or any functions that we define, or any data structures that we define, will basically be showing up here in this environment. If you look into history, we can also see, well, this for us right now should also be blank, but throughout the tutorial we're going to be doing various things, and basically every command that we execute within the RStudio terminal will then end up here in the history pane as well. And then finally here on the bottom right, we have the fourth pane where we can see files, we can see any plots that we create, we can see any packages that we've installed and loaded, and we can see, so we might want to be asking for help or so on. So here normally you'll be navigating between the files and the plots panes. So something that you will first realize is that everything you do here within RStudio, everything you want to work with and create, you're working from a certain place in your directories, in your computer. So basically in the folders on your computer, which we call directories, you're working in a particular location, and this is what we call the working directory. So to find out where this working directory is, we can use a function called getWD, like this. And if we run this line of code, it basically will tell us where we currently are. So I'm currently working in a directory called R tutorials. And when we see this kind of a structure, so a word or a number of letters followed by these parentheses, what it tells us is that we've executed a function. So all functions in R will look something like this: a word, which is the function, which will be followed by parentheses. And often inside these parentheses, we will put some kind of a data structure on which we're executing the function. But in some situations, such as getting the working directory, we don't need to specify what we're operating on, we just want to get the working directory. So we can also set the working directory if we want to change that. So let's say, for example, I wanted to go to a different working directory. I would use the set working directory function. And inside this, I would place the path, so what we call the path, to the folder where we have our R tutorials. So if, for example, this weren't the working directory, I would set it like this. I would set it like this, in quotes, and then I would run this line of code, and then the working directory would be here. So I mean, if, for example, I were to just set the working directory to documents, and then I were to again get the working directory, I would be told that I'm now just in documents. But I want to be in R tutorials, so this is where we are. And so how did we actually run this line of code? Well, what we did was we Well, what I was doing was using a keyboard shortcut, which is the Control-Enter. So if you press the Control key and the Enter key, this runs the line of code. But we can also do this by simply pressing the Run. And this will, line by line, allow us to run the code which we have here in our script. If we wanted to run the entire script, we could also use the source function, which we can do now because we don't have any other code in the script. But yeah, basically, this is how you run a line of code or a function. Okay, so the next thing I want to go into is data structures. So now that you know a little bit about what the RStudio interface looks like and what are the basic features of the interface, we can start off by looking at the different kinds of data structures that you can use within RStudio and some of the very basic functions that you will come across very often in your work in R. So if you're going to be working in R, most likely you're going to be working with some kind of data. So I, for example, work in bioinformatics, so most of my work in R is working with some kind of genomic data. And R can handle various different kinds of data structures depending on what your needs are. These different data structures can be something as simple as numbers, single numbers, like 1 is a numeric data structure, or strings of characters, which are basically words. A data structure basically refers to any particular way in which the data is organized or stored in RStudio so that we can use it in a most effective manner. And data structures can be one-dimensional, such as numbers. They can be two-dimensional, such as what we will call vectors, which we'll look at. They can contain many numbers or many characters, or they can be multi-dimensional, such as more complex structures like matrices, data frames, and lists, which we'll also take a look at. Usually, when we work with these different data structures, we assign them to what we call variables. So what this means is we basically give the data structure a name. So let's look at the basic kinds of data structure. Let's look at, 1. But 1 on its own, we haven't really saved anything. We have to always go back to 1. But if we want to save this into a variable, we can assign it a name. So to do this, we can say x, and then this assigns x to 1. We can also do x equals 1, but it's more proper to use this structure. And then, if we just type x, RStudio knows that we're talking about 1. If we were to do x equals 6, RStudio knows that we're talking about 6. Let's let y equal 10. And then we can perform some arithmetic on these. So we can try x plus y. RStudio knows that x is 6 and y is 10. So we can do all sorts of, mathematics. X multiplied by y, for example, and so on. We can also try like mean. This is a function. Mean xy. No, that's wrong. Mean cxy. Yes. So these are basically what we call numeric data structures. We can also create strings. So these are also one-dimensional data structures. We could let z equal caret. Now z is just caret. More likely we'll be working with some more complex structures. So two-dimensional data structures, normally these are what we call vectors. So a vector is basically an ordered set of different either numbers or categorical data. So let's say we want to create a vector. Let's again just use x to call our vector. And basically here we can give it many more elements than just one. So using this C notation, we can create a numeric vector containing various elements. And we can operate on this vector. As we did before, for example, we can write x plus 1, and this will add 1 to every element in x. If, for example, we wrote mean x, we can get the average of x, the average of all elements in x. We can do something like x multiplied by 2, which will multiply every element in x by 2. We can do something like x squared, which will square out every element in x. So there are many things that you can do with a numeric vector. And applying any function to a numeric vector will apply it to every element in that vector. We can also make character vectors, so as well as numeric vectors. Let's try trees. And then we can, again using this C notation, we can populate this trees vector with various different names of trees. So for example, birch, we can have oak, we can have pine. And of course, since this isn't a numeric vector, a lot of these functions are not going to be meaningful anymore. For example, if we wrote mean trees, we won't get the average of these trees because that's not logical. So we'll get a warning saying, argument is not numeric or logical, returning NA. Similarly, if we were to try to say trees plus 1, what would this give us? Error in trees plus 1, non-numeric argument. So there are certain functions which we can only apply to these numeric vectors and which aren't really meaningful for these trees vectors. But what we could do is we could add another tree to trees. So we could say more trees, let's give it a new name, and we'll make a new vector which is C, trees, and then ash. And then more trees is going to be a larger vector which contains all of the trees and trees as well as an additional. So we can combine various vectors or add to them in this way. So then, okay, so we've looked at numeric and vectors, so 1- and 2-dimensional data structures, but there are also what you will probably be using more often is more multi-dimensional data structures like matrices and data frames. So both matrices and data frames are basically tables, so they contain a number of rows and a number of columns and data within those rows and columns. And the main difference between these two structures, matrices and data frames, is that in matrices you can only hold one type of information. So either you have all numeric information, numeric data in a matrix, or you have all, let's say, character data. Whereas in data frames you can hold many different kinds of information. So you can have some columns which hold numeric data and others which hold categorical data. So let's create a basic matrix. We'll create a numeric matrix and we'll call it M. And we'll use the matrix function and we'll give it, let's say, 9 elements. We'll specify the number of rows, so 3, and we want to specify the number of columns, also 3. And what this should give us is a matrix which has 3 rows, 3 columns, and populated with these numbers. In a vector. Let's see what this does. And the result is something like this. So we get a matrix, 3 rows, 3 columns, and populated with the numbers that we specified. We could also do this, if we're looking at this kind of a sequence of numbers, we could do this similarly by simply writing 1 to 9. Because if we write 1 to 9 like this, it will just give us the sequence of 1 to 9. And again, if we say n row is 3, n col is 3, it should give us the same results. Now let's try and make a data frame. So a data frame, as we said, is slightly different because it can hold not only one type of data, but it can hold many different types of data. So let's make a data frame based on our trees and use the data frame function, data.frame, and let's make 3 different columns. So let our first column be trees, and then let's put heights outside of it. So let's make a vector of heights. and let's say 56, 23, 78. And then let's make a vector of locations. Let's say, for example, London, Berlin, Montreal. And then let's make the data frame df, data frame trees, heights, locations. And here we have created a data frame which will look like this. So we have 3 columns, and we'll see that the first column is categorical, the last column, locations, is also categorical, and the heights is numeric. So if we write str_df, we can see that. So character, trees, character, heights, numeric, locations, character. So that's a basic data frame. Then let's look at one final type of data structure, and in a later video I'll show you how to really work with these data structures and get information from them and add to them and so on. But for now, let's just look at one final data structure, a list. So a list is basically an ordered collection of objects, and they can contain any kind of object. So they can contain vectors, they can be lists of vectors, or they can contain lists of matrices, lists of data frames, and so on. And they can also contain mixtures of these. So let's just use the data structures that we've already created and create a list that contains our numeric vector x. So let's call the list L and use the list function. And let's make it contain x, which was the numeric vector that we defined earlier. Trees, a character vector, m, the matrix we created, and df, the data frame we created. And what L will now be is a list which looks like this, which holds all of the data structures which we've put into it. So the next thing that we're going to do is look at some of the plotting functions that we can have in R. So usually when you have data, you're going to want to visualize it in some kind of way. And in RStudio, there are many ways of doing that, but what we'll use today is what's called base R plotting, which means that we don't need to install any extra packages to use it. We just work with the functions that already exist within the base R. So to do this, let's work with the vectors and matrices that we previously created. So let's actually just work with this numeric vector x, which we previously created, to illustrate some of the plotting functions that we can use. So one kind of plot which we can do is just with the plot function will give us a scatter plot, since x is in this form. So if we just write plot x, it'll look like this. Basically, we've plotted x on the y-axis, and the x-axis is just telling us 1, 2, 3, 4, because those are the numbers, or the indices in x. But we could also make a scatter plot if we write, for example, plot x against x squared. And this will give us this kind of plot where on the x-axis we have x, the vector that we created, and then on the y-axis we have x squared. And we can add some more things to this plot. For example, we can add labels to the x and y axes using, so x lab. We can give it our numbers, and ylab can be our numbers squared. We can also add a title to the plot using the main argument, our scatter plot. And we can also do things like change what these points look like, so we can change their color using call. We can make them blue. This will be specifying a color inside quotes. We can also change the shape, so using PCH we can set it to something different. So now we'll see that these dots are filled in. There are many different ones. Let's try something like that. You can do what you like, play around with it. You can just Google this PCH if you want to see what the options are. Similar with colors, you can just Google R colors and it will tell you all the different colors that are available. And there are many different things that you can do with the plots like that. Another kind of plot we can try is a bar plot. So if we similarly write bar plot x, we'll get something like this, and we can put similar arguments, so it will be exactly the same if we want to specify, for example, ylab is our numbers. In this case, our numbers are here on the y-axis. And again, we can set like color is blue, or let's make it red. And main is bar plot. So, what else we can do? We can try a box plot. So if we just do a box plot on x, we'll get something like this. Let's make it a little more interesting. Let's make a box plot of x and then x multiplied by 5. And then we'll get something like this. And again, we can just make the y label. Let's just make the y label numbers. And color, let's give it 2 colors. We can give it 2 colors using a vector. So let's make the first box red or blue, the second box red, and it will look like this. There are some other things we can do, for example, pi. We can do this on our vector, kind of a plot. And yeah, so these are just some examples of the basic plots we can make. And as I said, I can go into more detail in some more advanced plotting functions using a package called ggplot2, for example, in a later video. So the next thing let's look at is saving and loading data. So if you have data in R and you want to save it, not just within this R session, but in a way that you can come back later and look at it, then we use various saving functions. If we want to save a plot, we can do this with a PNG or a PDF. Let's try, for example, PNG. And let's create a plot called mypi.png. And then let's write pi x. And then what this will do, we then will use this dev.off function, which will basically come out of the plotting function. And I want to create this PNG. And hopefully this will have created a nice pie plot that we can then look at like this. We could also try that as a PDF. So PDF. Let's do the box plot. And let's name it myboxplot.pdf. And let's give it certain dimensions, 4, 4. This is the width and this is the height. You can play around with those. And let's just write that plot here and we can open it. And what we should get is the box plot in a nice PDF. Okay, so now let's look at some different things that we can save and load. So we have created earlier a matrix called called M. We can write this to a file, so a text file, using, for example, write.csv. And this will write our matrix M to a text file which we can name matrix.csv. Let's see what this does. So what this does is creates a matrix which is now saved in our working directory. And we can open that up. We can see view file and then we have it right here. What I would actually have done is specify row names is false because I don't want these row names. So now we just have our matrix and these V1, V2, V3 are the columns that are by default assigned since our matrix didn't have its own column names. If we want to write to a tab separated file, so instead of this kind of a comma separated, we want it more like the columns are separated by tabs. we can use the write.table function. And let's write our trees data frame to trees.tsv. And let's again specify row names is false. That was not what I wanted to do. I wanted to save the data frame, df. And now we've got this data frame saved to a TSV file. We have the trees, their heights, their locations as we specified. Now what we can also do is read that data back into R. So for the purpose of this, let's remove our data frame. So we can use the rm function. So basically, if we now type df, we get our data frame of trees. But we can remove that from the current environment by using the rm. So if we rm df and then we type df, we no longer have it. So actually we just get, since df is a function, it tells us the function, but our data is no longer here. So we can see that our data frame is no longer visible in the global environment. Everything that we've previously created is here. We see our vector, we see trees, our character vector, we see more trees, and everything else that we've created, but df is missing. So this isn't a problem because we've saved our data frame into trees.tsv, and we can read it back into a data frame with the same name using read.table. So read.table trees.tsv. Let's say header is true. Let's see what this gives us. df, and there we have it again. And we can again see that df reappears in our global environment, and now it's visible to us again. We can do the same thing with our matrix m, which we created. We can remove it with the rm function, rmm. We can see that it's now disappeared from the global environment, but that's not to matter because we can read it again. And this time we'll use the read.csv function because we saved it as a comma-separated file. Matrix.csv, which we can also see here in our files. And let's again say header is true. And let's see what that gives us. And we've got again our matrix is back. Beautiful. So now that we know how to save data, how to load data, read it into R, let's look at a couple of final things before we round up this video. So we're going to look a little bit at our packages. So far, everything that we've been doing in R, we haven't been using any specific packages. We've actually just been using what are called base R functions, so functions that are automatically available within RStudio that we don't need to do anything extra to install them. But usually when you're working with R, you're going to need to do things a little bit more complicated, and so you're probably going to need to load and to install some specific packages. And so what an R package basically is a collection of R functions or data sets or other things that have been all put together by somebody in the R community so that they can be distributed and used easily by R users. And how we access these packages in the standard way is using this function called install.packages. And basically in install.packages we can specify the name of a package. Let's say, for example, ggplot2. I've already installed this package, so when I run this line of code, it won't actually want to install it. But let's say I want to load this package. I can do this using what's called the library function, library ggplot2, and now ggplot2 should be available to me. And so I should be able to use this for more complex plotting functions, which is what this package is used for. We won't go into that. And basically with our packages, we can view the packages that we currently have installed in this packages pane. So anything that we currently have already installed will be available here. In search, for example, for ggplot2, and we see that since we have installed it, it shows up here. And also since we have loaded it, we see that it's with this tick. So if we, for example, wanted to load this cowplot package, we could again use library cowplot, and we should see that cowplot is now loaded, so we'll see this tick appearing in the cowplot package. So that's how we install and load packages. Now there are some situations where packages are installed in a different way. For example, if you're working in bioinformatics, there are certain packages that are specifically used in biology, and these are held in a particular specific repository called bioconductor, and these are installed in a different way. But for now, installing and loading basic packages is with install.packages and with library. Now the final thing that I'm going to tell you about is how to get help and how to get documentation. So you might have also noticed that within this pane here, we also have help. And how we access help for a function, we can do this for a function or for a package, is using the question mark function. So it's quite intuitive. We have questions. We want to know what a certain package is for or what a certain function is doing. So if we were to simply ask, what does the mean function do? We can write question mark mean, and it will tell us, okay, this is a function, it's in base R, it's called mean, and more specifically, it's calculating the arithmetic mean. And then we can also see if there are other certain arguments. Let's try, for example, question mark bar plot. This will tell us, okay, this bar plot function, it's in the graphics package, which is also in base R. Description, it creates a bar plot with vertical or horizontal bars. And this is how we run the bar plot. And here we can see all the different arguments that can be specified within bar plot. So when we created our bar plot, we used, for example, the X lab, Y lab, but there are a lot of these arguments that we didn't use, but that can be used to make the plots more tailored to your preferences. And then we have a description of all the different arguments if you need that. This can be very, very informative. But we can also ask for help about a particular package. So these are functions, not packages. But if we wanted, for example, to know what does the ggplot2 package do, we can use the same question mark ggplot2, and this will give us a description of the ggplot2 package. So this is a package for creating elegant data visualizations using the grammar of graphics. And it will give us a description of the ggplot2 package, and it will give us some web links to where we can go to find out more about the package that we're interested in. Okay, so that's it for today's complete introduction to working in RStudio. And I'll leave some more links to some more resources and information about RStudio if you want to learn some more on your own. I'll also go into detail in some of the topics that we covered in future videos. So thanks a lot for watching and have a beautiful day.